Out there in the vast, silent theater of space, there are worlds that, they follow the rules, and then there are the outlaws. Today, we are on the hunt for a true cosmic fugitive, a world that exists in total defiance of everything we thought we knew about how planets are even born. Let's dive in and uncover its incredible story.
And look, that isn't just me being dramatic. It's the central puzzle that has astronomers completely baffled, but also totally fascinated. We're going to explore how scientists even found this impossible world, and more importantly, why its very existence is forcing us to rewrite the rulebook of the universe.
So our story doesn't even begin with a planet. It begins with a star. Hundreds of light years away, a pretty ordinary-looking star in the constellation Pisces Austrinus was hiding a massive secret. And the very first clue, well, it was almost impossibly small.
So yeah, how do you find a world you can't see? That's almost unimaginably far away. I mean, you can't just point a telescope and snap a picture. The glare from its own star is billions of times brighter. So instead, astronomers have to become cosmic detectives, and they have to look for clues hidden in the starlight itself.
So instead of seeing the planet, scientists saw what it was doing to its parent star. They noticed the star wasn't holding perfectly still. Nope, it was moving just a tiny bit back and forth in a really predictable rhythm. That little wobble was the telltale sign that something huge and invisible was gravitationally yanking on it.
And this is the brilliant trick they use. It's called the radial velocity method. Think of it like a cosmic dance. The planet and its star are dance partners, and they're orbiting a shared center of gravity. Now, because the star is so much bigger, it barely moves, but it does wobble. And that tiny little wobble is everything. Okay, so how do we measure that tiny wobble from light years away? The answer is something you've definitely experienced before, the Doppler effect. You know how an ambulance siren sounds higher pitched as it comes towards you and lower as it moves away? Same principle, but with light. As the star wobbles towards us, its light waves get squeezed, shifting to the blue end of the spectrum. As it moves away, they stretch out, shifting to the red. By measuring these tiny, rhythmic color changes, astronomers can spot the pull of an otherwise invisible planet.
So, after years of painstakingly watching that wobble, the culprit causing all this commotion was finally unmasked. It was time to meet the planet behind the mystery.
All right, here's the case file on our suspect. Its name is HD 137010b. It's a gas giant, a lot like our own Jupiter, and it's orbiting a star that's pretty similar to our Sun. But the key thing on this file is its status: extreme. And believe me, we're about to find out just how extreme it really is.
Just so we're all on the same page, let's be super clear about what we're dealing with. This is not a world like Earth, with rocks and oceans. HD 137010b is a gas giant, basically a colossal ball of gas with no solid surface at all. You couldn't land on it. You would just fall, sinking deeper and deeper into its crushing atmosphere.
Okay, so we found a big planet. Big deal, right? Well, the problem isn't that it exists. The problem is where it exists and how it's moving. And this is where the case gets really, really weird. When astronomers finally mapped out this planet's path around its star, they found something that seemed to just break all the rules of how planets are supposed to form. Its orbit is a complete mess. It's nothing like the stable, predictable solar system that we call home.
Just look at this comparison. Earth's orbit is a nice, gentle, almost perfect circle, which is why we have stable seasons. HD 13701010's B's orbit, on the other hand, is this crazy stretched-out oval. It plunges in super close to its star, getting absolutely blasted with heat, and then it swings way, way out into the freezing darkness. It's a world of insane extremes.
So in astronomy, there's a technical term for how stretched out an orbit is. It's called eccentricity. A perfect circle has an eccentricity of 0. Well, the orbit of HD 137010b is what we call highly eccentric. It's a very, very squashed oval. And that is the first major clue that something is deeply wrong with this picture.
So here they are, the official charges against this planet's existence. First, what we call the close orbit problem. Gas giants are supposed to form way out in the cold parts of a solar system where there's ice. So what is it doing so close to its star? Second, the eccentricity problem. The star's immense gravity should have smoothed out that wild oval-shaped orbit into a nice circle billions of years ago. So why is it still so stretched? And finally, the survival problem. How does this planet even hang together with the insane tidal forces and temperature swings it must experience on every single orbit?
And that is the million-dollar question, isn't it? If it didn't form there, and its orbit should have stabilized by now, what on Earth happened? Scientists needed a whole new story to explain this cosmic crime scene.
The leading explanation is every bit as dramatic as the orbit itself: planet migration. The idea is that this world didn't form where we see it today. It was probably born way out in the cold, distant regions of its system, just like our theories say it should. But then, something chaotic happened. Maybe a close call with another giant planet acted like a cosmic slingshot, violently flinging it into the crazy, eccentric inner orbit we see today.
You see, this one, single, strange world actually opens up a much bigger story. It's forcing us to realize that the neat, orderly blueprint of our own solar system, it's not the only way the universe builds a family of planets.
And here's a critical piece of evidence that really backs up that wild migration theory. HD 137110b isn't an only child. It's part of a multi-planet system. That means there were other massive objects around that could have gotten into a gravitational tug-of-war, ultimately kicking our impossible planet onto its new, strange path.
It's pretty incredible to think that, thanks to missions from NASA and the European Space Agency, we've gone from knowing only about the planets in our own backyard to confirming well over 5,000 worlds orbiting other stars. Our catalog of known planets has absolutely exploded, and with it, our understanding of what's even possible out there.
And it turns out that in the grand cosmic rulebook, weird is pretty much the new normal. We've found things like hot Jupiters that are practically roasting right next to their stars, rogue planets that wander through the dark all by themselves, and countless other worlds that just defy easy explanation. HD 137010b isn't some lone freak. It's a perfect example of the incredible and often chaotic diversity the universe is capable of.
And all of this brings us to a really profound conclusion. For centuries, we basically held up our own solar system as the universal model for how planets are supposed to behave. But discoveries like this one prove that assumption was just plain wrong. The universe is way more creative, chaotic, and varied than we ever gave it credit for.
And that leaves us with one last kind of mind-blowing thought. Every time we find a world that breaks the rules, it isn't a failure of our science, it's an invitation to a much deeper mystery. The fact that HD 137101b is out there proves that the cosmos is still full of impossible things, just waiting for us to find them.